In his book, The Greatest Show on Earth, The Evidence for Evolution, Richard Dawkins argues that denying evolution today is comparable to denying the Holocaust. The New York Academy of Sciences in New York City hosts this Our 20-Minute event.
We have a war on our hands. You've just heard that more than 40% of the US population, according to Gallup, believes that the world came into existence less than 10,000 years ago. That is a quite astonishing disconnect from reality. The reality is that the world is 4.6 billion years old, and I've mentioned this calculation many times before. The equivalent of believing that the world is only 6,000 years old, which is the official biblical figure, is to believe that the distance from New York to San Francisco is less than 8 yards. That's the scale of the error that we're talking about, and it's an error that, if Gallup is to be believed, is in the minds of 44% of the American population. At the beginning of this book, I have likened the predicament of a science teacher today to a Latin teacher, or teacher of Latin and Roman history, having to contend with a sort of rearguard defense, having to put out a rearguard defense of the proposition that the Romans existed at all, and that the Latin language was ever spoken, rather than being an invention to keep Victorian schoolmasters in employment. I've also likened the history denial shown by these young Earth creationists to Holocaust deniers, in the sense that the evidence for evolution is as strong as the evidence for the Holocaust. I hasten to say I'm not suggesting that evolution deniers are motivated by the same sinister political agenda as Holocaust deniers are. They're motivated by a different sinister political agenda. But I don't want to make this book seem like a negative, debunking kind of book. It isn't mainly that. The evidence for evolution is above all positive. It's enthralling. It's exciting. It is the greatest show on Earth. Life on this planet is the greatest show on Earth, and life on this planet may well be the greatest show in the universe, because we have no evidence that anything like the quite astounding phenomena of life are to be found anywhere else in the universe. Maybe they are, in which case life is the greatest show in the universe still. The first chapter also considers the definition of the word theory, which, as you know, is much misunderstood, and I quote two definitions from the Oxford Dictionary, one of which is the tentative, only a theory, only a hypothesis that needs falsifying or verifying, and the other being the sort of meaning that a scientist uses when talking about, say, the heliocentric theory of the solar system, or the theory of gravitation, or the atomic theory of matter. And it's, of course, in that sense that evolution is a theory, but in ordinary colloquial language, evolution is a fact. Chapter 2, Dogs, Cows, and Cabbages, follows Darwin in making use of domestication, the astonishing power of selective breeding to produce from a wolf, dog, or from the wild cabbage, Brassica oleracea, all the different varieties of cabbage-like plants that we eat, cauliflower, Brussels sprouts, broccoli, and various sorts of cabbage, and so on. If you wanted to do an experiment to test the theory of natural selection, what would you do? Well, experiment implies human intervention. What you would do would be to administer the selective force yourself as an experimenter. In other words, you would do artificial selection, which is what humans have done inadvertently at first in breeding dogs and cabbages and pigeons and so on. And also experimentally, there are now numerous experiments where people have administered a selective pressure on populations of animals and plants and produced dramatic results, dramatic evolutionary change in a very short time, within one human lifetime. A nice example is the work of Belayev, Russian geneticist who studied silver foxes and bred them artificially for tameness. And he succeeded in breeding super tame foxes, which behaved like dogs, licked your face, wagged their tail, behaved just like dogs. What's more interesting is that after only about 30 years, he has these foxes that look like dogs. They look like collie dogs, no longer look like foxes. They've got black and white patches on their coats. They've got floppy ears. They bark like dogs. That is a curious phenomenon of traits being dragged along in the wake of other ones. He selected only for tameness, but what he got was dog-like characteristics in all sorts of other respects. It's an interesting side glance. The important point is that he produced dramatic evolutionary change in a mere 30 years. And if you can do that in 30 years, just think what could be achieved in 100 million years. It would not be artificial selection, of course, it would be natural selection. Coming on to that. Chapter 3, the primrose path to macroevolution. This chapter is an exercise in seduction, starting with artificial selection, which we've just been talking about, showing the power of artificial selection. I'm trying gradually to wean the reader on to natural selection by going through a number of intermediate stages. The peahen selects the peacock in something like the same way as human breeders select Frisian cattle or white leghorn hens. Peahens, of course, don't consciously choose peacocks. They do choose peacocks on the basis of that which appeals to them aesthetically. You can use the word aesthetically. And the result is the astonishing, flamboyant splendor of the peacock. And the same thing happens with birds of paradise, numerous other birds, insects, fish, amphibians, mammals, and so on. Flowers, the brightness of flowers, the bright colors of flowers, the exotic, the seductive perfumes of flowers, these were, first of all, chosen by insects, choosing the flowers that they would visit to, and from the flower's point of view, pollinate. That's what the flower gets out of it. The insect gets nectar, of course, usually. What the insect started, human horticulturalists carried on with. So something like a wild rose, a pretty little flower, but nothing to compare with the beautiful roses that human gardeners have produced by artificial selection, the beautiful perfumes. What I'm saying, the point I'm making, is that what human selectors have done is simply to carry on where the insect selectors left off. So we can regard insects as doing the same kind of job as human artificial selectors. Anglerfish have a fishing rod sticking out of the top of their head with a bait on the end, and they play their prey, the small prey, down into the vicinity, cast the rod down into the vicinity of the mouth. Small fish are attracted to the bait. When they get sufficiently close to the mouth, the anglerfish opens up its great maw, and the inrush of water sucks in the prey. It's obviously a very sensible way to get prey. From the point of view of the victim, the prey fish, you could say that the prey fish are acting as selective breeders, selecting anglerfish for more effective bait. Now, obviously, it's not to the advantage of the prey to do that. Nevertheless, that is what they're doing. So you see how the primrose path to macroevolution, the seductive path, is working. I'm gradually moving towards natural selection. In natural selection, we've already got to natural selection, of course, but in ordinary natural selection, we generalize it and say that any variation, any genetic variation whatsoever, whether it's visible on the outside, as all the examples I've talked about so far have been, or a purely internal change, genetic change, some subtle detail of biochemistry, something that you'd never notice on the outside at all, if it contributes in any way to the survival or reproduction of the animal, that will be positively or negatively selected. We've moved now up the primrose path of seduction from artificial selection, which anybody can understand, and which was understood, of course, long before Darwin, to natural selection, which only Darwin and Wallace, it could be argued anyway, really grasped. It was Darwin and Wallace who saw the principle of artificial selection that everybody understood could be generalized to nature. Nature just means that some animals survive and some animals don't survive, for whatever reason. And that has exactly the same effect as if there was a human breeder choosing which puppies to save and which puppies to kill, which puppies to breed from, which puppies not to breed from. In order to get major macroevolutionary change, such as changing fish into mammals, you need time. Artificial selection, we've seen that in human terms in a few centuries, we've seen what can be done, but in natural selection, evolution, we've got hundreds of millions of years. We need to know how, we need to set out the evidence that we do have hundreds of millions of years. In Darwin's time, this was doubted. In Darwin's time, the senior British physicist of the day, Lord Kelvin, demonstrated to the satisfaction of himself and other physicists that the sun and the earth were only a few million years old, not long enough for evolutionary change. This worried Darwin because he was a humble man and he recognized, as many of us do, that physics is kind of the senior science. And so he never actually caved in, but it did worry him. The basis for Kelvin's miscalculation was that he, being a Victorian scientist, thought that the sun was doing combustion, was burning something. He didn't really think it was coal, but something like burning coal, in which case his calculation would have been correct. It's a nice quirk of history that it fell to Charles Darwin's son, Sir George Darwin. Charles himself was never knighted. His son, Sir George Darwin, to demonstrate to the British Association in the early 20th century that the sun, because it was a nuclear reactor, had plenty of time to have given all the time we need for evolution. What Darwin should have said to Lord Kelvin is, well, if your physics tells you that the Earth is not old enough for evolution to have taken place, then I'm sorry your physics is wrong, because the evidence from biology is overwhelming. That would have been the correct response. As it turned out, the refutation came finally from physics. My chapter mostly goes into the details of how we know how old the Earth is, how we know how old fossils are, mostly using radioactive dating. Physicists will tell us the half-life of isotopes, and these isotopes gives, for example, potassium-40 decays to argon-40 with a half-life of 1.26 billion years. At the moment when molten lava solidifies, crystals are formed, and at that moment you could say that the clock is zeroed. The potassium clock is zeroed, the argon-40 content is zero. And at any later time, if you measure the argon-40 content and the potassium-40 content and compare the two, knowing the half-life of this particular decay, you can calculate the exact moment, within ordinary limits of error, the exact moment when that crystal was formed, when that lava solidified. Fossils don't occur in igneous rock, so you have to look for igneous rock that is to be found in the vicinity of a fossil in sedimentary rock, and that's not too difficult to do, and the science of dating is now well developed, and it's how we know how old fossils are and how we know how old the Earth is, 4.6 billion years. There are other ways in which we know that as well. The next chapter, Before Our Very Eyes, I've said that mostly evolution takes a very, very long time, and there are exceptions to that. There are some cases where we see natural evolution taking place sufficiently fast that an individual scientist can study it within one scientific lifetime, a matter of decades. And I discuss a number of examples of this, but they're fairly few, these examples, compared with the evidence that we have from the massive amount of time that's been available for long-term macroevolution. And for that, I use the analogy, it's a recurrent analogy throughout the book, of a detective coming on the scene of a crime too late to be an eyewitness. And this would be the normal situation for a detective. It's not granted to many detectives to actually be eyewitnesses to a murder. They come upon the murder afterwards, and they then look at clues which remain. Fingerprints, footprints, bloodstains, all sorts of other things that are left lying around. And from this, the detective infers what must have happened. The equivalent for evolution is clues that remain, which hugely outnumber in number and strength the clues that are available to any detective in any ordinary murder mystery. So beyond reasonable doubt, which is the criterion that juries are supposed to work to, the evidence for evolution is far beyond reasonable doubt. It's just beyond all possible, conceivable, sane, sensible doubt. Chapter 6, missing link. What do you mean, missing? Creationists love the fossil record because they think it's an embarrassment to evolutionists, because they point out that there are gaps in the fossil record. Well, of course there are gaps in the fossil record. What do you expect? Would you expect every single species that's ever lived to fossilize? We're lucky to have fossils at all. If we didn't have a single fossil, if not a single corpse that ever fossilized, the evidence for evolution would be utterly secure. We don't need fossils to demonstrate evolution. It's nice that we've got them, because they tell us a lot about the history of life, but we don't need them to demonstrate that evolution is a fact. The evidence comes from other sources. The biggest gap, and the one that creationists love best of all, is the gap before the Cambrian era, just over 500 million years ago. Before that time, there were rather few fossils, and most of the major animal phyla appear relatively suddenly in the fossil record in the Cambrian. I wrote in an earlier book, I'm going to just read a passage. Yes, in The Blind Watchmaker in 1986, I wrote, "The Cambrian shows us a substantial number of major animal phyla already in an advanced state of evolution the very first time they appear. It is as though they were just planted there without any evolutionary history." You can see how naive I was in 1986 not to realize how shamelessly that would be quote mined. It's as though they were just planted there without any evolutionary history. Needless to say, this appearance of sudden planting has delighted creationists. I was savvy enough to realize that they would like that. I decided to search the World Wide Web for that sentence. It is as though they were just planted there without any evolutionary history, to see how many hits I got. And I obtained no fewer than 1,250 hits for that sentence. Well, you need a control, if you're a scientist, to compare that with, otherwise you don't know what you expect to get, how many hits you'd expect to get from a sentence like that. So I looked at the very next sentence from The Blind Watchmaker, which was, "Evolutionists of all stripes believe, however, that this really does represent a very large gap in the fossil record." The number of hits I obtained for that, as compared to the 1,250 for the first quote, the number of hits I obtained for the second quote was 63. The ratio of 1,250 to 63 is 19.8, and I call that ratio the quote mining index. The quote mining index is also very high for the famous quote from Darwin, where he talks about the eye and says something like, "To suppose that the eye, with all its," and he goes into detailed sentence about all the highly complicated ways in which eyes are adapted and adjusted and do self-focusing and self-stopping down. He says, "To suppose that the eye could have been formed by numerous small incremental changes seems absurd in the highest degree." He then, of course, goes on, but that's where the quote stops. And they miss out Darwin's immediately following explanation for how actually, although it seems absurd, it's not absurd. And once again, we have a very high quote mining index. The ratio, I've done it for that too, the ratio of the number of hits for the two quotes is also very high. What is... Well, before leaving the Cambrian explosion, I just want to make one more point. There are modern animals, for example, flatworms, the great phylum Platyhelminthes, which includes tapeworms and flukes, and free-living Turbellaria, which are beautiful animals, they're delightful animals, often very brightly colored, very ubiquitous, very common, enormously common. There are more species than there are of mammals, for example. Not a single fossil of a Platyhelminth has ever been found, or authentically found. In other words, we have here a major modern phylum which has no fossil history at all. It is as though it were planted here yesterday. So you see how illogical it is to say that because there are no fossils before a certain point, therefore there were no animals. There are all sorts of reasons why an animal doesn't fossil. It may be too small. It may be that it doesn't have hard skeletal parts. That's the case for the flatworms, for example. I'm going to read another short passage from this chapter. What would be evidence against evolution, and very strong evidence at that, would be the discovery of even a single fossil in the wrong geological stratum. J.B.S. Haldane famously retorted when asked to name an observation that would disprove the theory of evolution, "Fossil rabbits in the Precambrian." No such rabbits, no authentically anachronistic fossils of any kind have ever been found. All the fossils that we have, and there are very, very many indeed, occur without a single authenticated exception in the right temporal sequence. Yes, there are gaps where there are no fossils at all, and that's only to be expected. But not a single solitary fossil has ever been found before it could have evolved. That's a very telling fact, and there's no reason why we should expect it on the creationist theory. A good theory, a scientific theory, is one that is vulnerable to disproof, yet is not disproved. Evolution could so easily be disproved if just a single fossil turned up in the wrong date order. Evolution has passed this test with flying colors. Skeptics of evolution who wish to prove their case should be diligently scrabbling around in the rocks, desperately trying to find anachronistic fossils. Maybe they'll find one. Want a bet? The next chapter carries on the theme of fossils into human fossils. It's called Missing Persons, Missing No Longer. And I'm going to read just a little bit about the type specimen of Australopithecus africanus, which is the so-called Taung child. Australopithecus was the genus that almost certainly preceded our own genus Homo in our evolutionary ancestry. In other words, we're almost certainly descended from members of the genus Australopithecus, although it may not be any one of the species that have so far been named. The first Australopithecine to be discovered, and the type specimen of the genus, was the so-called Taung child. At the age of 3½, the Taung child was eaten by an eagle. The evidence is that damage marks to the eye sockets of the fossil are identical to marks made by modern eagles on modern monkeys as they rip out their eyes. Poor little Taung child, shrieking on the wind as you were borne aloft by the aquiline fury, you would have found no comfort in your destined fame 2.5 million years on as the type specimen of Australopithecus africanus. Poor Taung mother, weeping in the Pliocene. I want at this point to raise a point of terminology which I think is extremely relevant. The Taung child, I said, was the type specimen of Australopithecus africanus. That means it's the specimen that was first discovered and described and to which people refer when they have a new specimen and they want to know, does it belong to this species or not? So each new fossil, or new animal indeed, that's discovered is always given a Linnaean binomial name, a specific name preceded by a generic name, like Homo sapiens, Australopithecus africanus, or whatever it is. When a fossil is actually intermediate between two species or two genera, and on the evolution review there must be such fossils, we are not allowed by our conventions of nomenclature to give it an intermediate name. There's no machinery in language to give a name that is intermediate between, say, Australopithecus afarensis and Homo habilis. Yet if there must have been a member of the genus Homo that was the immediate child of a member of the genus Australopithecus, but you can immediately see that that's nonsense, because how could a baby be a different genus from its mother? Obviously, in every single case, every baby born is the same species, let alone the same genus, as its mother. If you were to walk backwards down through your ancestral tree, starting with your mother, and then your grandmother, great-grandmother, let's just stick to females for convenience, great-great-grandmother, and so on, you would go back and back and back and back and back, go back as far as you like, and gradually the animals that you were walking past, as you walk past your ancestors, would be gradually, ever so slowly changing into something else. By the time you got back to about 6 or 7 million years ago, you would be looking at an animal which was the common ancestor between ourselves and chimpanzees. And you could then, if you wish, turn around and start walking forwards along the line leading to chimpanzees. At every single point along that sequence, the animals that you are looking at would belong to the same species as their immediate neighbors, which would be their mother and their daughter. They would be more alike than members of species ordinarily are, because they would be mother and daughter, therefore they would be more alike. And yet, if you walk back sufficiently far, they would have changed from modern Homo sapiens to a completely different genus. You could go back to a fish using the same technique. And by the time you got to the end of your walk, you would have walked through a continuously changing set of animals, all the way from human to fish. And then you could walk forwards again from fish to, I don't know what, I mean, a kangaroo or something. In every single case, you would be seeing animals that are of the same species as their neighbors in the sequence. And yet the changes are so slow, but yet so persistent, that eventually you get back to a fish. It's not all that surprising, because after all, when a baby turns into an adult, you don't suddenly say, aha, it ceased to be a baby, it's now turned into a child. And then, aha, it ceased to be a child, it's now become an adult. It happens so gradually, you don't notice the change. We're like a flea sitting on the hour hand of a watch. You can't see it moving. It moves so slowly that you don't see it. Now, in spite of that, we do force upon every fossil that we find, by convention, the binomial name, either, say, Australopithecus afarensis or Homo habilis. And that's meat and drink to creationists, because whenever a fossil's found, it's either an ape or a human. We don't have a name for an intermediate. We can't call it an intermediate, because we don't have the nomenclatural apparatus to do so, and they prey on that convention. And maybe it's time evolutionists started, while never actually abandoning the Linnaean binomial convention, nevertheless admit that there may be times when a fossil doesn't deserve to be given a name, simply should be called intermediate between some other recognized fossils. Think about it another way. If every creature that had ever lived fossilized, then naming would be impossible. Everything would be intermediate. You'd have to give it a name that reflected the shading between species and genera. The next chapter, I'm just going to read the beginning. That irascible genius, J.B.S. Haldane, who did so much else besides being one of the 3 leading architects of neo-Darwinism, was once challenged by a lady after a public lecture. It's a word-of-mouth anecdote, and John Maynard Smith is sadly not available to confirm the exact words, but this is approximately how the exchange went. Evolution skeptic. Professor Haldane, even given the billions of years that you say were available for evolution, I simply cannot believe it is possible to go from a single cell to a complicated human body, with its trillions of cells organized into bones and muscles and nerves, a heart that pumps without ceasing for decades, miles and miles of blood vessels and kidney tubules, and a brain capable of thinking and talking and feeling. JBS. But, madam, you did it yourself, and it only took you 9 months. That chapter is about embryology and the important relationship between embryology and evolution. You can't understand evolution fully unless you have some grasp of the embryonic processes that generation after generation start with a single cell and give rise to an adult, which then reproduces, producing a new single cell, and so on. The processes of embryology are extremely complex. They themselves must have evolved, and that chapter is aimed at that understanding. The next chapter, The Arc of the Continents, is about the geographical distribution of animals and plant species in the islands and continents of the world, which, coming back to our detective analogy, are exactly what you would expect them to be if they had evolved, and exactly what you would not expect them to be if they had been created, especially if they had been released from Noah's Ark. I'll read a short paragraph or two from that chapter. It is almost too ridiculous to mention it, but I'm afraid I have to, because of the more than 40% of the American population who, as I lamented in chapter 1, accept the Bible literally. Think what the geographical distribution of animals should look like if they'd all dispersed from Noah's Ark. Shouldn't there be some sort of law of decreasing species diversity as we move away from an epicenter, perhaps Mount Ararat? I don't need to tell you that is not what we see. Why would all those marsupials, ranging from tiny pouched mice through koalas and bilbies to giant kangaroos and diprotodonts, why would all those marsupials, but no placentals at all, have migrated en masse from Mount Ararat to Australia? Which route did they take? And why did not a single member of their straggling caravan pause on the way and settle in India, perhaps, or China, or some haven along the Great Silk Road? Why did the entire order Edentata, all 20 species of armadillo, including the extinct giant armadillo, all 6 species of sloth, including extinct giant sloths, and all 4 species of anteater, troop off unerringly for South America, leaving not a rack behind, leaving no hide nor hair nor armor plate of settlers somewhere along the way? Why did all the penguins undertake the long waddle south to the Antarctic, not a single one to the equally hospitable Arctic? Once again, I'm sorry to take a sledgehammer to so small and fragile a nut, but I have to do so. I have to do so because more than 40% of the American people believe literally in the story of Noah's Ark. We should be able to ignore them and get on with our science, but we can't afford to because they control school boards. They homeschool their children to deprive them of access to proper science teachers. And they include many members of the United States Congress, some state governors, and even presidential and vice presidential candidates. They have the money and the power to build institutions, universities, even a museum where children ride life-size mechanical models of dinosaurs with saddles, which they're solemnly told coexisted with humans. We can't afford to be snooty in Britain about that. 28% of the British population get their science from the Flintstones as well, believing that humans coexisted with dinosaurs. The next chapter, The Tree of Cousinship. Here I think we come to perhaps the most powerful evidence of all for evolution, looking at the enormous numbers of modern species that there are and comparing them systematically. Darwin was able to do this with anatomy, skeletons, for example. He was able to see that the hand of a man and the wing of a bat are directly homologous. A bat's wing is enormously long, splayed out fingers with webbing stretched between the fingers. A horse's hoof is the same hand where, of the 5 fingers, only the middle one remains, and the horse walks on the middle finger and the middle toe, and the hoof is the nail. And you can see that, you can see it in the fossil record, how the number of fingers diminished, and there are occasional freak horses which are born with 3 toes, showing an intermediate stage. But that was the limit of what was possible in Darwin's time. You could compare anatomy and show very, very convincingly that it fell on a family tree. Nowadays you can do the same thing with molecules, with genes molecularly analyzed. And the sheer amount of information available is multiplied many orders of magnitude. Because the genetic code is universal, all creatures have the same machine code, the same code whereby triplets of DNA are rendered into amino acids. You can directly compare the same gene in one animal with the same gene in another animal. You know it's the same gene. It's got essentially the same sequence with minor differences. There's a letter different here, a letter different there, a letter different there. And the corresponding differences appear in the amino acids and in the protein chain that they produce. But you can say this is the same gene, it's doing the same job, it's got the same sequence with these minor differences. And then you can literally count the number of differences between these genes. It's not a case of saying, oh, this limb looks a bit like that limb. You are literally comparing alternative texts, just like alternative versions of the book of Isaiah or something, where you just count the number of differences that there are between chapters, between letters, between sentences, words. And when you do that, for any one gene you like, you find that the differences fall on a beautiful hierarchical tree. What could that be but a family tree? What could that be but a pedigree? Then you do the same thing for another gene, and you find the same tree. And then you do it for another gene, and you find the same tree. Then you do it for a gene which no longer does anything, but you can still sequence it. Nature doesn't read the gene anymore. It's never translated into protein. But molecular geneticists can read it, and they can recognize that it is a defunct version of the same gene. And again, when you compare these pseudogenes, you find the same family tree. There are minor exceptions to that. But in general, it's dramatically true that if you look at different genes, you find they fall on the same tree. What could that tree be but a family tree? The only alternative is that the intelligent designer, the creator, deliberately set out to deceive us and make it look as though evolution had happened when it didn't. That's not a resort that I think many theists would wish to cling to. Next chapter, history written all over us. When you look at modern animals, you don't need to look at fossils, just look at modern animals, and you can see their history written all over them. Look at a dolphin, look at a whale. It's a purely aquatic animal, lives only in the sea. But you can tell from looking at it that it has all the hallmarks of a land mammal. It's descended from a land mammal. Our bodies, any animal's body, has mistakes which no designer would ever have perpetrated, and yet which clearly are understandable if you think historically, if you think this is descended from an ancestor which did things differently. I was privileged to be attendant, I suppose would be the right word, on a dissection of a giraffe's neck a few months ago, while I was writing the book, in fact. And we were dissecting the recurrent laryngeal nerve of this giraffe, which had unfortunately died in a zoo. The recurrent laryngeal nerve is it's a branch of one of the cranial nerves. It starts in the brain, and its end organ is the larynx, the voice box. So you might think that if a designer had made this nerve, he would have made it go straight from the brain to the larynx, which is what most nerves do. This nerve, however, goes right past the larynx, way down into the chest, loops around one of the main arteries in the chest, different one on different sides, and then goes back up to the larynx. In a human, that's a detour of a foot or so. In a giraffe, it's a detour of 15 feet or so. I watched this nerve as it was being dissected out. It goes within an inch or so of the larynx, and it goes straight past it, and then goes on south, on and on and on and on, down into the chest, turns around and goes back up again. No designer in his senses would ever have done that. Yet it makes perfect sense when you think of it historically, when you look back to the fish ancestors of mammals, where that nerve was doing something very different, and the most direct route to what was then its end organ was indeed posterior to the artery that we're talking about. Then when mammal necks started, when fish don't have necks, when mammal necks started to elongate, it might have been possible to loop the nerve over so that it went north of the artery instead of south of the artery. But in fact what happened was that it just stayed elongating as the neck lengthened. The marginal cost of elongating the detour was so slight compared to just the enormous cost of, or what probably would have been an enormous cost of changing the embryonic processes in order to completely reroute the nerve into what would be a more economical way of doing it. The marginal cost was slight, just another millimeter. What's another millimeter? Evolution happens gradually, just elongate it a bit more. Human designers, intelligent designers of all kinds, go back to the drawing board when they've got a new design. When the jet engine, when the jet plane was invented, when the jet engine was invented, the designer of the first jet engine started with a clean drawing board. He didn't start with a propeller engine and then modify it rivet by rivet, screw by screw, nut by nut, which is the equivalent of the way evolution has to work. Imagine what a jet plane would look like if it was a gradually step-by-step modified propeller plane. That's the limitation under which evolution is working. Given that, it's amazing that animals work so well. The reason they work so well is despite these bodges, these bungles, as we would look at, as an engineer would call them, evolution, natural selection is a brilliant tinkerer that comes along afterwards and makes corrections after the event. So, for example, with the vertebrate retina in the eye, which is back to front, once again, what an atrocious piece of bad design that is. The photocells that are detecting the light are facing backwards, and the wires that connect them to the brain are in front, in the way of the light, and they have to dive through the retina in the so-called blind spot. What designer would ever have done that? Yet we see very well, because natural selection makes up for the initial bodge by superb tinkering of detail, which means that we end up seeing very well. Arms Races and Evolutionary Theodicy, Chapter 12. The evolutionary arms race, I think, is a very important and interesting idea. Animals become adapted to their environment, but if the environment is the inanimate environment, like the weather, say an ice age comes, and then a drought comes, and then a flood comes, and something else comes, the evolution of the animals just tracks the environmental change. When the cold weather comes, they get shaggier coats. When the cold weather goes, the coats become less shaggy. This all happens in evolutionary time. But what if it's not the weather we're talking about, but predators? Predators are actually getting better at being predators because they're evolving too. On the other side, prey animals are getting better at getting away from predators. And so unlike the weather, which is maybe unpleasant, but it's not deliberately out to get you, predators are. And prey animals are deliberately out to get away from you. And they're getting better at it. And so in evolutionary time, we see an arms race where the predators get a bit faster at running, and the prey animals have to get a bit faster, and the predators get faster, and it goes on escalating until now you see superb feats of speed by cheetahs and leopards on the one side, and by gazelles, antelopes, zebras, American antelopes on the other hand, on the other side. And when you look at any beautifully designed, apparently designed piece of biological machinery, like an eye or a knee joint, a fast-running leg, an efficiently pumping heart that goes on for a long time. What you're looking at is the end product of an evolutionary arms race, of several evolutionary arms races, run in evolutionary time, not to be confused with the race that's run in real time between an individual leopard and an individual antelope. So the arms race is a race to improve the equipment for survival. And this is an economical shift. It's got to be an economic shift into the weaponry of the arms race, whether it's long-running legs or sharp teeth or keen eyes or whatever it is, from something else in the economy of the body, because the body is a very thrifty economy, has to be, like, for example, making milk. If only the leopards and the antelopes could come to some kind of trades union agreement that they're not going to, that say the antelopes are going to send a tithe of their number to be eaten each year, then neither side would have to develop fast-running limbs at all. They could just get on with the business of reproduction. Everybody would be better off, but of course that's not how evolution works. Evolution works at the individual level. I'm going to read a little bit about arms races. One thing about arms races that might worry enthusiasts for intelligent design is the heavy dose of futility that loads them down. If we're going to postulate a designer of the cheetah, he has evidently put every ounce of his designing expertise into the task of perfecting a superlative killer. One look at that magnificent running machine leaves us in no doubt. The cheetah, if we're going to talk design at all, is superbly designed for killing gazelles. But the very same designer has equally evidently strained every nerve to design a gazelle that is superbly equipped to escape those very same cheetahs. For heaven's sake, whose side is the designer on? When you look at the cheetah's taut muscles and flexing backbone, you must conclude that the designer wants the cheetah to win the race. But when you look at the sprinting, jinking, dodging gazelle, you reach exactly the opposite conclusion. Does the designer's left hand not know what his right hand is doing? Is he a sadist who enjoys the thrill, who enjoys the spectator sport and is forever upping the ante on both sides to increase the thrill of the chase? Did he who made the lamb make thee? Is it really part of the divine plan that the leopard shall lie down with the kid and the lion eat straw like the ox? In that case, what price the formidable carnassial teeth, the murderous claws of the lion and the leopard? Whence the breathtaking speed and agile escapology of the antelope and the zebra? Needless to say, no such problems arise on the evolutionary interpretation of what is going on. Each side is struggling to outwit the other because on both sides, those individuals who succeed will automatically pass on the genes that contributed to their success. Ideas of futility and waste spring to our minds because we are human and capable of looking at the welfare of the whole ecosystem. Natural selection cares only for the survival and reproduction of individual genes. Now, finally, the last chapter is called "There is Grandeur in This View of Life," which you'll recognize as a quotation from Darwin. It comes from the very last paragraph of The Origin of Species. And my last chapter takes each sentence of Darwin's last paragraph and makes each sentence into a section heading of my last chapter. And the body of the section is an exegesis of that sentence of Darwin. And the last sentence of Darwin's book is, "Endless forms, most beautiful and most wonderful, have been and are being evolved." And I'm going to read the last page of the book in conclusion. The fact of our own existence is almost too surprising to bear. So is the fact that we are surrounded by a rich ecosystem of animals that more or less closely resemble us, by plants that resemble us a little less and on which we ultimately depend for our nourishment, and by bacteria that resemble our remoter ancestors and to which we shall all return in decay when our time is past. Darwin was way ahead of his time in understanding the magnitude of the problem of our existence, as well as in tumbling to its solution. He was ahead of his time, too, in appreciating the mutual dependencies of animals and plants and all other creatures in relationships whose intricacy staggers the imagination. How is it that we find ourselves not merely existing, but surrounded by such complexity, such elegance, such endless forms, most beautiful and most wonderful? The answer is this: it could not have been otherwise, given that we are capable of noticing our existence at all and of asking questions about it. It is no accident, as cosmologists point out to us, that we see stars in our sky. There may be universes without stars in them, universes whose physical laws and constants leave the primordial hydrogen evenly spread and not concentrated into stars. But nobody is observing those universes, because entities capable of observing anything cannot evolve without stars. Not only does life need at least one star to provide energy, stars are also the furnaces in which the majority of the chemical elements are forged, and you can't have life without a rich chemistry. We could go through the laws of physics one by one and say the same thing of all of them. It is no accident that we see ... The same is true of biology. It is no accident that we see green almost wherever we look. It is no accident that we find ourselves perched on one tiny twig in the midst of a blossoming and flourishing tree of life. No accident that we are surrounded by millions of other species, eating, growing, rotting, swimming, flying, walking, burrowing, stalking, chasing, fleeing, outpacing, outwitting. Without green plants to outnumber us at least 10 to 1, there would be no energy to power us. Without the ever-escalating arms races between predators and prey, parasites and hosts, without Darwin's war of nature, without his famine and death, there would be no nervous systems capable of seeing anything at all, let alone of appreciating and understanding it. We are surrounded by endless forms, most beautiful and most wonderful, and it is no accident, but the direct consequence of evolution by non-random natural selection, the only game in town, the greatest show on earth. Thank you very much. I'm very happy to take questions. I think that this mic needs turning on.
No?
Yes.
Yeah, okay. So I think there are intelligent designers at work. They're called molecular biologists. And I was wondering what you think the implications are for the course of evolution of our ability to modify plants and animals and us eventually.
Intelligent designers have been around for a long time, of course, long before molecular biologists, because it was intelligent designers who made Brussels sprouts and Pekingeses and domestic roses. So all that's new is that instead of only having control over the selection part of the Darwinian process, we now have control over the mutation part as well. We can cause genetic changes, whereas before we simply had to wait for them to happen. So that is a big difference, and it is already having dramatic impacts on our control over the evolutionary process. But we've had a fairly good control over it for a long time, starting with inadvertent control and moving on to the more systematic and deliberate control of scientific agriculture and horticulture and plant and animal breeding.
Cool. A lot of scientific innovations have led to a better understanding of anomalies and discrepancies. For example, the general relativity finally explained the discrepancies.
Is that mic on?
Yep. Oh, sorry. I'm not close enough. Sorry. I will start again. A lot of scientific innovations have led to a better understanding of anomalies and discrepancies. For example, the general theory of relativity led to a better understanding of the discrepancies of Mercury's orbit. We have plenty of anomalies left in science, such as dark matter, dark energy, the pioneer anomaly, lucid theory of everything, that kind of stuff. what discrepancies do you think would lead to, if we investigated them more, would lead to a better understanding of evolution?
Yeah, that's a very interesting question. I think that particular model of the history of science works very well for physics. It's not easy to see quite how it would work in evolutionary science. I suppose you might say that the theory of punctuated equilibrium could be regarded as an example of that, where the discrepancies that were observed were apparent departures from the expectation of gradualness towards the view that the apparent gaps in the fossil record might not be the actual gaps. It might actually really represent a genuine punctuation event. I don't favour that theory as much as some people do. I think it probably works in some cases. Anyway, I don't need to go into that now. That might be one possible example. There probably might be others. I'd need to think about that. Thank you.
Thank you.
Thank you for an engaging talk. Darwin considered changing the term natural selection to natural preservation. I believe I read in a letter of his. What would be the implication to the greatest show on earth with the concept of natural preservation over selection?
Darwin was worried, and Wallace was even more worried, by the implications of the word selection, which seemed to many people to imply deliberate selection. I mean, the word selection, I think that was the problem. And this was why Wallace urged Darwin to adopt Spencer's term, survival of the fittest, which again is like natural preservation. It conveys a more passive view of the process. Wallace said that to him and to Darwin himself, the idea of natural selection was as plain as daylight. But to many people it was not, and to many people, and it's undoubtedly true that in Victorian times, people did think that there had to be some kind of selector. They just couldn't quite grasp the idea that it really was just preservation. It really was just the survival of the fittest. I'm not sure that many people have that problem now. I think people have other problems now. Survival of the fittest gave rise to all sorts of other confusions, which I think are even greater than the confusions that the Victorians saw in natural selection.
Hi. Do you think life has a natural tendency to get more complex with time, or it's just random, like if we all go extinct in 100 million years, another intelligent species will show up, or...
Right. I don't think it'd be right to talk about an intrinsic tendency to get more complex. It probably is true that natural selection under the right conditions, and I think especially of arms races, will make things get more complex. There's no law that it has to get more complex. Parasites are the famous case where they tend to get less complex. So there's no drive to become more complex. There's no urge to become more complex. But when you have predators chasing prey and prey running away from predators, then you tend to get more complexity to a prodigious extent. I mean, the complexity of a mammal, or indeed a bird or a reptile, is gigantic. And I think you can largely put that down to competitive arms races with enemies. But it's not an internal drive to get more complex.
Evolution and natural selection seem so elegantly simple, especially compared to relativity or quantum theory. So I'm wondering if you're ever surprised that it took until the 19th century for the theory
It surprises me hugely. I mean, when I compare what Darwin achieved to what Newton achieved 2 centuries earlier, it seems to me that what Darwin achieved should have been a doddle compared to what Newton achieved. And yet it took 2 centuries longer. And I've often wondered what it was that made it so difficult to get it. You certainly don't need to be a mathematician to get it. It came independently to 2 English travelling naturalists. It evaded great thinking philosophers and mathematicians down the ages. Anybody could have thought of the idea from an armchair from the time of the Greeks onwards. They never did, or not properly. Ernst Mayr, who died only a couple of years ago at the age of 100, thought that the stumbling block was what he called essentialism, philosophical term, which conveys the idea that animals and plants have a kind of essential, have an essence, which is as fixed and unalterable as, for example, the essence of a triangle. It comes from the Greeks, who were geometers at heart, and a triangle is a figure with a fixed definition. A triangle is a triangle is a triangle. It's a polygon with three sides. And people seem to see rabbits and rhinoceroses as though they were triangles, incapable of changing into anything else. It's not clear to me why they should have thought that, but that's Meyer's diagnosis, that people could see how you could get kind of minor changes within rabbit kind, but the idea of extrapolating those minor changes until a rabbit turned into something quite different, you no longer call a rabbit. Even a fish turning into a human after a sufficient length of time, that seemed to be beyond people. Maybe because the sheer time it takes is greater than people can grasp. We're so used to the idea that rabbits are rabbits that we don't live long enough to see them turn into anything else. But it's a real mystery why the achievement of Darwin, which seems so simple, took so much longer. Or maybe it was that the achievement of Darwin, which was to show that you can get from, without any design at all, that you can produce structures so complex that it seems like utter and complete common sense they must have had a designer. Maybe that is so far from common sense that people who had the intellect to do what Darwin did, it just wouldn't have even occurred to them to even doubt the possibility that something as complicated as a brain or an eye or a heart could have had no designer.
Excuse me. So lateral gene transfer challenges your ideas that all genes in the same organism have the same evolutionary history. And creationists have been using this to say, well, since we can't know the true tree of life, that obviously something's wrong. And I'd wonder if you could address that and when you were going to address that in a book of yours.
There was an issue of New Scientist which appeared earlier this year with the dramatic headline, "Darwin was wrong." You can imagine how the creationists used that. It turned out, if you actually read the article, that it was nothing to do with Darwin being wrong. What it was about was lateral gene transfer. What it was about was that in some organisms, almost all of them, microorganisms, bacteria, genes move sideways. They don't stay in longitudinal lineages like they do in mammals and birds and most of the larger creatures that Darwin himself was familiar with. Now, it is true that if you look at bacteria, you no longer get the nice simple rule that says every gene comes down from parents, grandparents, great-grandparents, great-great-grandparents, and so on. Because we have that rule in the animals we're familiar and plants that we're familiar with, the tree of life is a simple branching tree. It never meets branches. Once they've separated, once the species has split into two, and there's a little bit of a sort of fudge going on while they're splitting when some kind of crossbreeding becomes possible, is possible, remains possible. Once they've split sufficiently far apart, they no longer interbreed, and there is never again any lateral gene transfer. From then on, the tree of life goes on branching and branching and branching without any anastomoses, without any networking, without any crossing over. That's not true of bacteria. In bacteria, they promiscuously and liberally adopt a kind of copy and paste policy with respect to genes. Bits of genome are just simply copied from one bacterium and pasted into another one with abandon. And so it's true that at the root of the tree of life, where we have bacteria, it's, as I think Dan Dennett said, it's more like a banyan tree than an oak tree. It's got a massively crossing gene transfer. So you've got to do a special trick when you get to the bacteria. You no longer think of individuals as gene machines that are struggling to pass on their genes longitudinally down through the generations. However, the idea of the selfish gene still works a treat. The selfish gene is simply trying to maximize its own propagation into the future. And if it can do it by copying and pasting itself into another bacterium, so much the better. So not only was Darwin not wrong, because Darwin didn't know about bacteria, Dawkins wasn't wrong, because at the level of the selfish gene, this is a happy hunting ground for selfish genes, is dashing around from bacterium to bacterium like quicksilver. That's wonderful stuff for the selfish gene.
Yeah. I have 100 questions, but I just limited to one. So I read the New York Times review of your book by Nicholas Wade, and he actually took you to task. It was largely a positive review, but he took you to task for asserting that evolution is a fact. And as a technical point, he made an argument that it's a theory, and then actually accused you of having a, I'm not sure if I get this right, but I think it's a lack of appreciation for the cognitive nature of science.
Yeah.
Which is, I was insulted for you, but
yes.
I'm not even sure what it is.
Yes. Nicholas Wade was, I have to say, very unfairly treated by the commenters to my website, richarddawkins.net, where we posted this. He really got a bit of a drubbing there. I think it boils down to the difference between what philosophers of science say, where you wouldn't wish to say that anything was a fact. I mean, you would wish to say that everything that we ordinarily call a fact is just a hypothesis that hasn't been disproved. So it is not a fact that the world is round and not flat. It is a hypothesis that has never been disproved. Now, as Stephen Jay Gould said, there does come a point where that kind of kowtowing to philosophy of science needs to sort of merge into a bit of common sense. And the way he put it was, there comes a point where it becomes simply perverse to say, well, we're still waiting to see if this hypothesis is going to be disproved. The hypothesis that the world is round and not flat is never going to be disproved. And the same, I would maintain, is true of evolution. So while it's right to say that philosophers of science would prefer not to use the word fact, because the word theory is so wantonly misunderstood by lay people, egged on and abetted by creationist propaganda, we are better off using a word that ordinary lay people understand, such as fact, because we're using the word fact in exactly the same way as, for example, a court of law would use the word fact. If a lawyer wagged his finger at you and said, is it or is it not a fact that you were in New York on the night of September the 24th, you would not say, well, it's a hypothesis that's difficult to disprove or something of that sort. You would answer, the lawyer would have you on toast if you said something like that. You would have to answer either it's a fact or it's not a fact. That's the sense in which evolution is a fact. The same as the fact that I'm standing at a wooden lectern in New York City.
Hi. It seems like we're making good progress as a species and a society. We don't think that the Earth is the center of the universe, and we're not like using leeches anymore to treat people. Well, some people are, but
leeches are coming back.
And in our country, you know, we're moving towards being allowed to do stem cell research, but at the same time, we've got like Sarah Palin, and like we had a president who said that the jury was out on evolution. So, do you think that we really are moving in the right direction overall? And are these things just sort of setbacks that we shouldn't lose too much sleep over?
I do think setback's a good word. I think what we have is a progressive movement which is not steady but has a kind of sawtooth effect to it. There's politics going on here, of course. When something like the Sarah Palin phenomenon is probably not really about scientific truth. It's probably about political, what shall we say, grievances. Maybe there's a sort of inferiority complex among people who don't have a very good education against people who do. I suspect there may be something like that going on here. But I am enormously encouraged as I go around the country, and I tend to make a point of going to places not like New York. I mean, I tend to go to places which are the so-called Bible Belt. And I'm hugely heartened by the warmth of the reception that I get in places like Oklahoma and Kansas and Alabama, great big crowds cheering. And I think it's because they feel beleaguered. I think it's because they find that somebody coming in from the outside who can say what he likes because he's flying out of the next plane. And they hear somebody articulating what they feel, but perhaps are intimidated from saying because they don't want to be ostracized at the golf club or whatever it might be. And people say that to me in the book signing queue over and over again. They thank me for coming. They say, thank you for coming to Kansas. We needed somebody to say what you've just said. This is what I feel. And they suddenly notice a whole lot of other people in the hall, thousands in some cases, and they recognize that they're surrounded by people. Admittedly, they're in a minority, but they can see that they're not alone. And I think that's leading to a change. I think you see it on the internet. I think it may be leading to a sort of critical mass phenomenon, whereby once the numbers of such people grow beyond a certain point, it'll suddenly go, and you'll suddenly notice a dramatic change.
This is less of a biological question, more of a philosophical one, but I think there's a biological slant to it. So do you subscribe to the theory of determinism, or do you think there's any biological evidence that indicates free will in humans or animals?
Determinism, in the philosophical sense of whether every event that happens in the universe, indeed, is determined and in principle predictable from earlier events, is not a question which a biologist needs to answer separately from philosophy or physics. This is a more general question. Physicists may answer using the idea of quantum indeterminacy, and that might be relevant to biology if quantum indeterminacy affects biological events, such as whether or not a nerve cell fires at a particular moment or not. I don't have the expertise as a philosopher to say whether it is right that all events in the universe are predetermined by other events, and certainly being a biologist doesn't give one any right to make such a thing. What I can say as a biologist is that the idea of genetic determinism, which is a much more restricted meaning of the word determinism, the idea that everything about us is determined by our genes, is not justified by the facts, and is nothing whatever to do, contrary to many critics, nothing whatever to do with the theory of the selfish gene. The theory of the selfish gene has been widely misunderstood as a genetic deterministic theory, misunderstood by those many people who have omitted to read the rather large footnote to the title of the selfish gene, which is the book itself.
Hi, Dr. Dawkins. That was a great talk. My question also is a little bit philosophical, as specifically the extension of evolution beyond biology into a term you coined and an idea that's often attributed to you, and that's memetics. It seems like you've been a little, or from what I've read, a little bit hesitant to endorse the idea. I know you're not, you're not against it or anything. I read your foreword in Susan Blackbourne's book, but I was wondering if you had, what reasons you had, or why you weren't such a proponent.
My hesitancy is just that I was never intending to offer a theory of human culture. That would have been presumptuous coming from a biologist. What I was trying to do at the end of The Selfish Gene was to downplay the importance of the gene as the only unit of natural selection. The whole of the rest of the book emphasized the gene as the unit of natural selection, because genes do have certain very important properties, namely high-fidelity self-replication and a powerful influence over the world, which affects their own probability of being replicated, namely through phenotypes. And so in ordinary biology, you cannot do Darwinian theory without talking about genes. However, a generalization of Darwinian theory, such as might take it to other planets, for example, would look for any kind of self-replicating information which had those same properties of high fidelity coupled with the ability to exert power over the probability of self-replication. And I speculated that on other planets, if there is life, it will be Darwinian life, but it probably won't be DNA-based life. It'll probably be some other kind of self-replicating coded information. And then I suggested, to make it easy to understand, maybe we don't need to go to other planets. Maybe we've got one staring us in the face on this planet. And that was where memes came from. Maybe the sort of soup of human culture, which is all our brains interacting with each other and passing information when we copy, when we imitate, when information flows from one brain to another. Is it possible to identify units of information being transferred which have high fidelity and which perhaps have power over their probability of, in this case, being imitated, and I think they are. I mean, I mentioned things like tunes that people whistle in the street and that other people pick up. You catch it like a virus, and you hear this damn tune and it goes around in your head and you can't get rid of it. And so you whistle it and somebody else hears it and he whistles it and somebody else hears it and whistles it, and it will spread through a whole lot of people. And the same could be true of all kinds of things, clothes, fashions, not just in humans. I mean, habits, great tits in England, when we had milk bottles delivered on doorsteps, learned, individual genius great tits and blue tits, learned to open the milk bottles, and then others watched them and imitated, and it spread literally like an epidemic. You could actually trace this habit, non-genetic, it's entirely non-genetic, spreading like an epidemic, like a measles epidemic around the country through various focal points. Natural selection theoretically could work on replicators of that kind. And in that case, we would have mimetic selection, mimetic evolution.
Excuse me. My question is actually more of a comment or observation. Sometimes I feel that part of the problem with the lay public not understanding evolution is that we evolutionary biologists don't always give a complete answer. So, for example, when asked to explain evolution, we usually go into something that explains natural selection and give an example like the industrial melanism moths or antibiotics or pesticides. But at the end of the day, you've still got moths or bacteria or insects. And it seems like that what we usually forget is that in the process of speciation, you need to have geographic isolation producing reproductive isolation. And we oftentimes leave that out. And
well, we oftentimes do, but I'm happy to say I didn't.
Yeah, and you're absolutely right.
And I didn't talk about peppered moths at all.
And what we need are more examples of the speciation process than just natural selection.
Okay, I take your point. Good.
Yes, Professor Dawkins. The extraordinary similarities between ourselves and other species that evolutionary biology helps us understand, do you think it has an ethical implication in terms of our treatment of non-human animals? I mean, in my understanding, you are not a speciesist.
I think it does have ethical implications. If you think about the way in which we give special treatment to humans, for example, in the case of abortion, human fetuses are treated as babies. And a lot of people think that it's murder to abort a human fetus, whereas they quite happily go and eat a cow, which of course has much more capacity to suffer than any human fetus does. Now, evolution immediately has an impact on this debate, because if you think going backwards through evolution, at some point we are connected to cows. I mean, I did it earlier, but you could do it for any pair of animals you like. Chimpanzees, which are pretty close to us, are not given anything like the same ethical, moral, legal protection as humans are. What would we do? What would those speciesists do if a live specimen of Lucy, of Australopithecus afarensis, were to be discovered? Would we have, and suppose all intermediates were available, suppose there were discovered relict populations in the forests of Africa between humans and chimpanzees all the way up to the hairpin and back down again, so close to each other that it would be possible for a human to interbreed with an intermediate who could interbreed with the next intermediate, who could interbreed with the next, and so on, who could finally interbreed with a chimpanzee. How would you police, how would you decide on the ethical discrimination between humans and chimpanzees? Would we have South African-style apartheid courts to decide whether Lucy passes for human, for example? Immediately, now, it's a fortunate, from my point of view, fortunate accident that those intermediates are all now extinct. But if they weren't extinct, we couldn't do the sort of speciesist discrimination that we do, and that fact that they might not be extinct should immediately give uneasiness. It's a pure accident that they're extinct. We ought to be able to do something about our morals and our ethics, taking account of the fact that they might not have been extinct. It shouldn't, this major ethical distinction should not depend upon the mere accident of extinction.
Hi, Dr. Dawkins. I'm a big fan. I have, most of the elders in my family are like myself, devout Christians. How do I, and they also don't really believe in evolution, how do I convince them to read your book or at least consider evolution without making a personal attack on their faith?
It shouldn't seem like a personal, I mean, it's not only a personal attack on their faith. A personal attack on somebody's faith is often interpreted as a personal attack on them. It has a deep emotional wounding effect. It's like saying they have an ugly face or something like that. So it's very difficult. I mean, I think you can only reason them to say, look, the disagreement is a mere disagreement about cosmology, about biology. Why should this be such an immense barrier? Why should you resist so strongly when you don't resist an argument about the quality of a piece of music or the quality of a football team or the quality of a play or the quality of a book? But when it comes to religion, you suddenly feel all emotionally bound up with it. I should have thought that wouldn't be beyond the grasp of most people. But I admit it is very, very difficult, and I wish you luck in your endeavor.
You know, dogs and wolves still can interbreed. Looking back at the point of bifurcation in the development of new species, all the species that are defined as species lose the ability to interbreed. So is there some sort of a common process in all of life that says once you reach a certain point, you can't interbreed anymore? Yes,
it happens first when the chromosomes of the two, if you take a hybrid, like say a hybrid between a donkey and a horse, a mule or a hinny, the chromosome, the genes can still work to produce an animal, and a mule is a perfectly strong and fit animal. But when it comes to make sperms or eggs, the chromosomes need to come together in order to perform the process of meiosis. And if there's a sufficient difference between the chromosomes, as there is between horses and donkeys, then the chromosomes can't come together in meiosis, and so the animal cannot make gametes. It can't make viable sperms or eggs. That's the first thing that happens. The later thing that happens is that the animals don't even want to mate with each other because they look too different or smell too different. So it is a gradual process. It doesn't, there's a sudden curtain comes down. It says, right, you're now separate species, you can't interbreed. What happens is it's usually in geographical isolation. The ancestors of horses and donkeys would have been split by some kind of geographical barrier, and they would have drifted apart, or maybe been selected apart, sufficiently far that when they met again, they either didn't want to breed again or couldn't breed again, interbreed again, and that's the point where biologists come along and say, okay, they're now a different species. It is a gradual process, but once it's happened, it's never reversed.
Thank you very much, Dr. Dawkins. I just want to say thanks for taking our questions. Thanks for great questions. I appreciate it. And keeping the time.
Richard Dawkins is a professor at Oxford University. He's the author of The Selfish Gene and The God Delusion. For more information, visit richarddawkins.net.
Among other titles, Tina Brown is the co-founder of the
and bred them artificially for tameness. And he succeeded in breeding super tame foxes, which behaved like dogs, licked your face, wagged their tail, behaved just like dogs. What's more interesting is that after only about 30 years, he has these foxes that look like dogs. They look like collie dogs, no longer look like foxes. They've got black and white patches on their coats. They've got floppy ears. They bark like dogs. That is a curious phenomenon of traits being dragged along in the wake of other ones. He selected only for tameness, but what he got was dog-like characteristics in all sorts of other respects. That's an interesting side glance. The important point is that he produced dramatic evolutionary change in a mere 30 years. And if you can do that in 30 years, just think what could be achieved in 100 million years. It would not be artificial selection, of course, it would be natural selection. Coming on to that. Chapter 3, the primrose path to macroevolution. This chapter is an exercise in seduction, starting with artificial selection, which we've just been talking about, showing the power of artificial selection. I'm trying gradually to wean the reader on to natural selection by going through a number of intermediate stages. The peahen selects the peacock in something like the same way as human breeders select Frisian cattle or white leghorn hens. Peahens, of course, don't consciously choose peacocks. They do choose peacocks on the basis of that which appeals to them aesthetically. You can use the word aesthetically. And the result is the astonishing, flamboyant splendor of the peacock. And the same thing happens with birds of paradise, numerous other birds, insects, fish, amphibians, mammals, and so on. Flowers, the brightness of flowers, the bright colors of flowers, the exotic, the seductive perfumes of flowers, these were, first of all, chosen by insects, choosing the flowers that they would visit to, and from the flower's point of view, pollinate. That's what the flower gets out of it. The insect gets nectar, of course, usually, applies to nature. Nature just means that some animals survive and some animals don't survive, for whatever reason. And that has exactly the same effect as if there was a human breeder choosing which puppies to save and which puppies to kill, which puppies to breed from, which puppies not to breed from. In order to get major macroevolutionary change, such as changing fish into mammals, you need time. Artificial selection, we've seen that in human terms. In a few centuries, we've seen what can be done. But in natural selection, evolution, we've got hundreds of millions of years. We need to know how, we need to set out the evidence that we do have hundreds of millions of years. In Darwin's time, this was doubted. In Darwin's time, the senior British physicist of the day, Lord Kelvin, demonstrated to the satisfaction of himself and other physicists that the sun and the earth were only a few million years old, not long enough for evolutionary change. This worried Darwin because he was a humble man and he recognized, as many of us do, that physics is kind of the senior science. And so he never actually caved in, but it did worry him. The basis for Kelvin's miscalculation was that he, being a Victorian scientist, thought that the sun was doing combustion, was burning something. He didn't really think it was coal, but something like burning coal, in which case his calculation would have been correct. It's a nice quirk of history that it fell to Charles Darwin's son, Sir George Darwin. Charles himself was never knighted. His son, Sir George Darwin, to demonstrate to the British Association in the early 20th century that the sun, because it was a nuclear reactor, had plenty of time to have given all the time we need for evolution. What Darwin should have said to Lord Kelvin is, well, if your physics tells you that the Earth is not old enough for evolution to have taken place, then I'm sorry your physics is wrong, because the evidence from biology is overwhelming. That would have been the correct response. As it turned out, the the refutation came finally from physics in kind of book. It isn't mainly that. The evidence for evolution is above all positive. It's enthralling. It's exciting. It is the greatest show on Earth. Life on this planet is the greatest show on Earth, and life on this planet may well be the greatest show in the universe, because we have no evidence that anything like the quite astounding phenomena of life are to be found anywhere else in the universe. Maybe they are, in which case life is the greatest show in the universe, still. The first chapter also considers the definition of the word theory, which, as you know, is much misunderstood, and I quote two definitions from the Oxford Dictionary, one of which is the tentative, only a theory, only a hypothesis that needs falsifying or verifying, and the other being the sort of meaning that a scientist uses when talking about, say, the heliocentric theory of the solar system, or the theory of gravitation, or the atomic theory of matter. And it's, of course, in that sense that evolution is a theory, but in ordinary colloquial language, evolution is a fact. Chapter 2, Dogs, Cows, and Cabbages, follows Darwin in making use of domestication, the astonishing power of selective breeding to produce from a wolf, dog, or from the wild cabbage, Brassica oleracea, all the different varieties of cabbage-like plants that we eat, cauliflower, Brussels sprouts, broccoli, and various sorts of cabbage and so on. If you wanted to do an experiment to test the theory of natural selection, what would you do? Well, experiment implies human intervention. What you would do would be to administer the selective force yourself as an experimenter. In other words, you would do artificial selection, which is what humans have done inadvertently at first in breeding dogs and cabbages and pigeons and so on. And also experimentally, there are now numerous experiments where people have administered a selective pressure on populations of animals and plants and produced dramatic results, dramatic evolutionary change in a very short time, within one human lifetime. A nice example is the work of Belayev, a Russian geneticist who studied silver fox. What the insects started, human horticulturalists carried on with. So something like a wild rose, a pretty little flower, but nothing to compare with the beautiful roses that human gardeners have produced by artificial selection, the beautiful perfumes. What I'm saying, the point I'm making, is that what human selectors have done is simply to carry on where the insect selectors left off. So we can regard insects as doing the same kind of job as human artificial selectors. Anglerfish have a fishing rod sticking out of the top of their head with a bait on the end, and they play their prey, small prey, down into the vicinity, cast the rod down into the vicinity of the mouth. Small fish are attracted to the bait. When they get sufficiently close to the mouth, the anglerfish opens up its great maw, and the inrush of water sucks in the prey. It's obviously a very sensible way to get prey. From the point of view of the victim, the prey fish, you could say that the prey fish are acting as selective breeders, selecting anglerfish for more effective bait. Now, obviously, it's not to the advantage of the prey to do that. Nevertheless, that is what they're doing. So you see how the primrose path to macroevolution, the seductive path, is working. I'm gradually moving towards natural selection. In natural selection, we've already got to natural selection, of course, but in ordinary natural selection, we generalize it and say that any variation, any genetic variation whatsoever, whether it's visible on the outside, as all the examples I've talked about so far have been, or a purely internal change, genetic change, some subtle detail of biochemistry, something that you'd never notice on the outside at all, if it contributes in any way to the survival or reproduction of the animal, that will be positively or negatively selected. We've moved now up the primrose path of seduction from artificial selection, which anybody can understand, and which was understood, of course, long before Darwin, to natural selection, which only Darwin and Wallace, it could be argued anyway, really grasped. It was Darwin and Wallace who saw that the principle of artificial selection that everybody understood could be generalized.
In his book, The Greatest Show on Earth, The Evidence for Evolution, Richard Dawkins argues that denying evolution today is comparable to denying the Holocaust. The New York Academy of Sciences in New York City hosts this hour 20-minute event.
We have a war on our hands. You've just heard that more than 40% of the US population, according to Gallup, believes that the world came into existence less than 10,000 years ago. That is a quite astonishing disconnect from reality. The reality is that the world is 4.6 billion years old, and I've mentioned this calculation many times before. The equivalent of believing that the world is only 6,000 years old, which is the official biblical figure, is to believe that the distance from New York to San Francisco is less than 8 yards. That's the scale of the error that we're talking about, and it's an error that, if Gallup is to be believed, is in the minds of 44% of the American population. At the beginning of this book, I have likened the predicament of a science teacher today to a Latin teacher or teacher of Latin and Roman history having to contend with a sort of rearguard defense, having to put out a rearguard defense of the proposition that the Romans existed at all and that the Latin language was ever spoken, rather than being an invention to keep Victorian schoolmasters in employment. I've also likened the history denial shown by these young Earth creationists to Holocaust deniers, in the sense that the evidence for evolution is as strong as the evidence for the Holocaust. I hasten to say I'm not suggesting that evolution deniers are motivated by the same sinister political agenda as Holocaust deniers are. They're motivated by a different sinister political agenda. But I don't want to make this book seem like a negative debunking